This is the introduction to fracking pipelines in the North American energy market. In this module, we will talk about natural gas, fracking or hydraulic fracturing, and pipelines and market integration. So is natural gas the more environmentally friendly fossil fuel? Maybe. Natural gas is composed mostly of methane with small amounts of other heavier hydrocarbon gases like ethane, propane, and butane. There's less carbon dioxide per kilowatt hour of energy produced than any other fossil fuel, including coal. And this is one of the main reasons that environmentalists like to tout natural gas as being an environmentally friendly option. There's significantly less nitrogen oxides than oil or coal and virtually no sulfur dioxide or particulate matter. So in general, it's just much cleaner than coal and oil. However, the production of natural gas might reduce incentives to invest in renewable energy, and we'll talk about why that might be the case. What do we use natural gas for? We use it for electricity generation. 36% of U.S. natural gas consumption in 2016 was for electricity generation. So we have generators that use coal to produce electricity, water in hydroelectric dams, etc. Natural gas is 36% of energy consumption, or generation and consumption. We use it for heating in our homes and in buildings, water heating. A lot of people have natural gas water heaters in their houses. Some people, fewer, have electric water heaters, but that electricity is probably produced from natural gas. So we use natural gas for all sorts of heating, cooking, and for residential and commercial users. We use it for industrial processes like melting steel or glass. And we use it as a feedstock for chemical manufacturing, fertilizers, for example. There are distinctive seasonal patterns to natural gas use for residential consumers and electricity generation, also for industrial and commercial consumers. So this figure on the right shows these seasonal patterns. So the x-axis is time. So we have 2010 M1, which means month 1 or January. 2011 M1 is month 1 or January for 2011, etc. So these are the winters at the demarcations. And we see peaks in residential, commercial natural gas use during the winters. Why might this be the case? What is it used for? It's used for heating. So when houses are being heated, we see peaks in residential and also commercial buildings are being heated. We see those peaks in the winter when we need the heat the most. The opposite holds true for the electric power sector. So we see the peaks in natural gas consumption in the electric power sector come during the summer months. Why might this be the case? What do we use during the summer that uses electricity? The answer is air conditioning. So we see large spikes in AC use during the hot months or the summer months, and we need electricity to power the AC, and the electricity comes from natural gas. Where do we get our natural gas from? A lot of it at this point comes from shale oil and gas fields in the United States. We'll talk about whether or not the oil or the natural gas market is globally integrated. A little spoiler, it's not. So most of the natural gas consumed in the U.S. is also produced in the U.S. and it comes from the fields outlined in this map here, the little brown areas. A lot of the oil or the natural gas at this point comes from fracking, which is comes from these shale oil fields. I should say that oil and gas they come from the same wells. So when a company taps a well, a shale well, they get some amount of oil out of it and some amount of natural gas out of it, some fraction of each. And each well has a different composition. So you might have a well that has 50-50 natural gas and oil. One might have 60-40 oil and natural gas, and the next one might have the opposite, 60-40 natural gas and oil. The fracking boom has led to rapid increases in U.S. natural gas production, pushing down domestic prices. So here's the natural gas production for Canada, Mexico, and the U.S. The fracking booms really started around 2006, and that's evident in this graph. You can see the blue line, natural gas production was fairly steady in the U.S. Until about 2006, and then it started ramping up. What it's done is it's pushed down domestic natural gas prices, and that's really as we saw in the beginning of the class, that's really the driver of what's shutting down coal plants. Let's talk a little bit about what fracking is. You've probably heard about fracking, and you've also watched the intro video on fracking that is posted on Canvas, hopefully. So let's discuss what it is. So fracking refers to hydraulic fracturing, the forcing open of fissures in the subterranean rocks by introducing liquid at high pressure, especially to extract oil or gas. They're actually shooting liquid down into rocks miles underground and cracking them open. Horizontal drilling and fracturing techniques have been around for decades, but recent technological innovations decrease the cost of using these techniques to extract oil and gas. They also go, so they tend to go down and then horizontal. So they'll go down vertically down about a mile or so, and then they can go up to 5 miles horizontally. So one well drilled in any particular location can be tapping oil and natural gas anywhere within a 5-mile radius. What Cushing, Oklahoma is to oil, this is, remember from the oil lectures, this is where oil is traded, and that's where the WTI price, the West Texas Intermediate price, is referring to. What Cushing, Oklahoma is to oil, Henry Hub, Louisiana is to natural gas. This is the hub of natural gas trading. NYMEX natural gas futures contracts are based on the price in Henry Hub, Louisiana. So the WTI is based on the price in Cushing, Oklahoma. The futures price for natural gas is based on the price in Henry Hub. While oil prices are typically quoted in dollars per barrel, natural gas prices are usually quoted in dollars per million metric BTU. Are the markets globally integrated? Unlike oil, large price variation shows that the world natural gas market is not fully integrated. This graph over here on the right kind of demonstrates that. The red line is the price for natural gas in Japan. The green line is the price for natural gas in Germany. Blue, natural gas price in the UK. And the orange line is the natural gas price in the US. You can see right around the fracking boom, we see a decline in the natural gas price in the US, but also elsewhere. So the main cause of the decline around 2007-2008 was the recession, but oil prices and natural gas prices in the US remain low. Oil prices around the world remain low, but then natural gas prices in the US remain low relative to elsewhere afterwards, and that's due to fracking. But the main point of this graph is that there's variation, geographic variation in the natural gas price, which means that the market is not globally integrated. Compared to natural gas, oil prices are globally integrated. So this is a reminder from the previous module that there is a global market for oil, but not natural gas. And this graph on the right highlights a slight discrepancy in that concept. So they're globally integrated for the most part, but as you can see, In this graph, we have the WTI price, the green line, and the Brent price. So the WTI price is essentially the benchmark for American oil, and the red line, the Brent price, is the benchmark for European oil. And they diverged at some point. So if I told you that the market was globally integrated, why are these lines diverging? Well, let's figure this out. The U.S. had remarkable growth in its oil production because oil and natural gas are intertwined. So as we saw with the natural gas production, the oil production also shot up around 2006 in the U.S. So this should just be dumped onto the global market or into the global bathtub. But something was happening that made that not the case. So what explains the divergence of oil prices in 2011 to 2014? What explains that divergence between the WTI and the Brent price? Large increases in oil production from the northern U.S. and Canada. We saw that on the previous slide. So we have an unexpected increase in supply in the U.S. and Canada from fracking. The oil pipeline capacity in the U.S. was configured to move oil from the Gulf Coast north to refineries in the Midwest, not the other way. The oil pipelines typically moved oil from the Gulf north, and the oil was coming in, it was imported oil into the Gulf, and then it was shipped north to Midwestern refineries. But we had all this unexpected supply in the Midwest and in Canada. The increase in production in the north led to an oil glut, or too much oil, at the Cushing hub in Oklahoma, which is the settlement point for the WTI. This pushed down the price at Cushing compared to the price in the rest of the world, the WTI versus the Brent. It created an arbitrage opportunity for anyone who could move oil from Cushing to the Gulf Coast. In essence, there was a transportation bottleneck. The pipelines were full going from the south to the north, and there was no capacity to move the oil from the north back down to the south. So they were trying to get rid of the oil in the north, but they couldn't, so they had to sell it at a lower price. Why are there large price differences for natural gas? Well, it's not globally integrated. Unlike oil, there is no integrated world market for natural gas. Natural gas is more expensive to transport than oil. Oil we can put in pipelines very easily. It's a liquid. We just dump it into a pipeline and let it move at 1 or 2 miles an hour. We can also put it in boats and let it sail around the world for months on end. It doesn't go bad. There's two alternatives for moving natural gas. There's natural gas pipelines, but that's much harder to deal with because natural gas, of course, is a gas, and so the pipelines leak. It's much harder to contain the gas than it is to contain the oil. They condense it to the other is that you can condense it to a liquid by lowering its temperature to negative 260 degrees Fahrenheit, then transporting the liquefied natural gas in specialized ships. So that obviously costs a lot of money because you have to build up pressure and decrease temperature. And then in order to ship it around the globe, you have to have specialized ships that can keep it at that low temperature. Much more expensive. The U.S. is a very limited participant in the world natural gas market. We have very few liquefied natural gas import terminals, and until recently, no liquefied natural gas export terminals. So the reason the natural gas market is not globally integrated is essentially transportation constraints, transportation difficulties. Here's the U.S. natural gas pipeline network. You can see there's a lot more pipelines than there were in the oil markets, and that's simply because we need to ship most of our natural gas by pipeline. We have alternatives for oil. We can do some by rail. So should the U.S. participate in the world natural gas market? An increase in supply of natural gas in the U.S. due to a fracking boom has pushed down domestic prices of natural gas compared to prices in Europe and Asia. So there's an arbitrage opportunity. We can sell our natural natural gas producers in the U.S. can sell their natural gas for more elsewhere. Many firms sought approval to build liquefied natural gas export facilities to take advantage of this opportunity. So firms saw this and asked the federal government, can they build export facilities to sell their natural gas elsewhere? Suppose the government approved the construction of these LNG export terminals. Who would be better off and who would be worse off? Let's find out. So before we look at the benefits and costs of doing so, let's look at the current state. Unfortunately, liquefied natural gas exports no longer look profitable. Liquefied natural gas prices collapsed in 2016. That's shown on the graph to the right. Natural gas in Europe and Asia is still sold with prices benchmarked to oil prices, so oil price declines led to sharp drops in natural gas prices in these countries. So we saw oil price declines in Europe and Asia during this period, and the price of natural gas in those areas is benchmarked to the oil price, and so the natural gas price declined. 4 LNG terminals currently are under construction in the U.S., but they may not be completed because of the declines in the natural gas prices elsewhere. They may give up on them. But what about Mexico? Natural gas consumption in Mexico is increasing rapidly, with imports increasingly important. So this graph shows natural gas consumption in Mexico in red and natural gas production in Mexico in green. You can see they were basically trending together until about 2000, when the consumption outpaced production. So there's a market down in Mexico for U.S. natural gas if we can get it there. Alternative opportunity for exporting natural gas from the U.S. by pipeline to Mexico. There's opportunities for both countries to benefit from the construction of natural gas pipelines between them. The government of Mexico is undertaking an ambitious project to build out natural gas infrastructure. Pipeline imports grew from 20.6 billion cubic meters in 2014 to 29.9 billion cubic meters in 2015. So Mexico's imports grew a lot in 1 year. LNG imports fell from 9.4 to 7.1 billion cubic meters over the same period. So the pipeline's imports are non-LNG. This is just pure natural gas, not liquefied. They purchase more imported natural gas via pipelines and less liquefied natural gas imports, probably because LNG is more expensive. The pipeline imports will continue to grow as new pipelines are completed. So now I want you to take an online quiz on natural gas and pipelines.